Friends, we are zipping in. If you'd like to go with me in your textbook, we are on these special senses. They are beginning upon the page that has the number 267. Mariah went way past it here. I don't know where she's going. 267, yes. 267. All right. So, you did some work yesterday. And again, I apologize I was not with you. What I do want to make sure you know is, I put this up on Schoology, but I'm saying it to you now as well, that tomorrow I would like the questions from 10.1 to 10.6. There's been a number of class periods now that I've given you to work on these guys. I would like those for tomorrow. Okay? So, and that runs us through the sense of taste, by the way. That's as far as we're going with those questions. Okay, so, special senses. We spent a bunch of time talking about general senses, pain in particular, right? And pain and pressure, right? And temperature. These were our general senses. And now we're talking about special senses. What those are what you actually think of as senses, right? You're seeing and smelling and tasting and touching and hearing, right? So, but equilibrium is also another one. We don't usually think of that as being a sense, but it is. And we'll talk about that one as well. So we're starting with olfactory. Olfactory is, of course, your sense of smell, right? Sense of smell. Okay, what kind of receptors do these olfactory receptors use? Remember our kinds of thermoreceptors and mechanoreceptors, right? They use chemoreceptors. Because in actuality, what's happening when you taste, stay with me, friends. What's happening when you taste is that the chemicals, whatever it is that you are smelling, have to actually be dissolved in that saliva, or in that watery fluid, not saliva, saliva's in your mouth, the watery fluid in your nose, the mucus, right? So when you are smelling something, there are literally little particles of that are in your nose. Sounds kind of gross, but that's just how it works. In some ways, yes. Yes. Okay? So these receptor cells, if you take a peek. Yes, sir. I suppose theoretically, yeah. Or perhaps there just aren't chemoreceptors that are affected by that certain something. Does that make sense? Okay. So I remember that I want to make sure that these folks, maybe you who are listening later, can actually hear this. So conversations, keep them quiet. Take a peek here. This is a zoomed in, but look over here on the right and you can see this is the olfactory bulb, right? Our first cranial nerve coming out and laying right on top of that cribriform plate. Remember this? The base of your skull. And here are the little roots. Like I said, it's almost like here's a tree and they're taking and letting it grow down through that cribriform plate, through the bone, into your nasal cavity. And you breathe in, and that air comes up through the nose, up into this very top part of your nose, which is where those nasal fibers are. If you want to smell something, what do? You put your nose closed, but then what do? You breathe fairly deep, right? It's not like unless it's really stinky, you don't really want to smell it, right? But if you really, you waft it in, sure. You have to breathe deep because you want that air to get all the way up into the top part of this nasal passage, which is where those receptors are. Question? Does what now? Sure, right. So, I don't know why that's probably why. So, if there is a bunch of mucus that's here, right? When you have a stuffed nose, right? Yeah, it's a good color, right? Yeah. Then yeah, it's literally blocking those receptors, and you can't smell. Okay? Does that make sense, my friends? So when those receptors are stimulated, it sends that signal up those neurons to that olfactory bulb, which again, it's lying on either side of the crystal galley on top of the cribriform plate, right? That impulse then, there's actually a little bit of analyzing that happens in the bulbs themselves, but then it sends that signal back toward the brain on that olfactory track into the cerebral cortex. Temporal lobe in particular is where you do your smelling at. Are you with me? Any questions as far as smell goes? By the way, you know that smells are very much associated with memory? Right? Anyone have this? Like you smelled a certain thing. Yeah, and it takes you to this place, right? Yeah. For me, the two biggest ones for me are freshly cut grass. It makes me feel like it's just summer. Like I just want to play, you know? And the other one, and you'll laugh at me, it's the smell of my baseball glove. That leather smell, that's like, it's tasty. Sure, sunscreen, the beach, right? That's a fantastic one.
Have you seen that commercial by some chemical company, Glade or Airwick or something like that? Glade. But then they have a way now to capture smells. So they can actually like mimic the chemicals that something gives off.
Sure.
Makes a smell.
Yeah.
And they can capture it in the candle.
Interesting.
Send it. So there was a commercial where like they captured the smell of the baseball glove, like you said.
Yeah.
The apple pie from the guy's plate.
Sure.
Something else. They sent it to this guy who was deployed in Iraq.
Isn't that cool? That is very neat. Sure. That is very cool. I had not heard that. If you've ever gone to a spa, right? And they very purposefully make sure the smell is a certain way to make it calm and relaxing, right? It's good. All right, next. One more piece. The olfactory receptors do adapt very quickly, thankfully. You're sitting in a room and, there's that smell that perhaps someone has produced that is not that fun. Thankfully, your nose does adapt. The particles stick around a lot longer than you think, but your nose adapts, thankfully, a little better. Okay? Good. Your next special sense we'll talk about here is your sense of taste. Now, truthfully, your sense of smell, olfactory, and sense of taste, the gustatory, G-U-S-T-A-T-O-R-Y, gustatory sense, are very interconnected. We were talking about, Brenda, when you're sick, right? When your nose is stuffed. Have you noticed you can't taste? Or your taste is significantly diminished? Yeah, right, you just can't smell the phone, you're all stuffed up. Yeah, I'm with you. Okay? So, the receptors that perform this sense of taste are on your tongue, within the papillae of the tongue, and are also scattered throughout the mouth. So here's your picture of your tongue, and you can see that there are, if you look close at your tongue, this is what you all can do in the mirror, and you see there's like these little islands that you think those are your taste buds, but actually they aren't. The taste buds are inside there. Okay, the actual cells. Shh. Here are your receptors, right? These yellow ones here. Stay with me, friends. Shh. And you can see that it's not the top that's doing the recepting, it's these side areas over here is where those actual taste receptors are. Which makes a little bit of sense, by the way, because are you comfortable that there's a lot of abrasions that happen up top here? You drink a hot drink, or you chew something that's especially, painful to chew. You don't want to necessarily damage those taste receptors. You do, to be honest, but But they're a little bit more protected on the sides there like that. Question? I truthfully don't know. That perhaps some of these are not, don't have the taste receptors. They're just the parts of the tongue. I don't know enough about the anatomy to answer that question. Madam? Sorry? She was asking why some of these have like the circles on the inside and some don't. Shh. Yes, you do. Yeah, no, we'll talk about that in just a moment. Yeah, absolutely.
So how come cats' tongues feel like that?
Good, because cats' tongues actually do. They have little hairs. You'll see this when we get our cats. That they have like literally these little hooky hairs on their tongues, and that's how they groom themselves. No, it's different. It's different for them. They still have those things, but they have other structures as well that you and I don't have. Or at least I don't. I don't think that you do. Okay, good. All right, where are we? Here we go. Okay. So those taste cells, those gustatory cells, are contained in those taste pores. So here we are. Here's your taste cell, the yellow piece, with the tiny little taste hairs. That these are the actual receptors. Oh, what kind of receptors do you think these are? Chemoreceptors, absolutely. Responding to different chemical compounds. Okay? Again, the chemicals must be dissolved in the water, in the saliva in your mouth for you actually to taste. The sense of taste isn't totally understood. They don't really understand exactly how that works, but there's certainly certain proteins that are bonding to those receptors that causes a signal that says, oh, this is sweet, or oh, this is salty, or because there are 5 different types of taste. And you can see them here. Sweet, sour, salty, bitter, and umami. It's a Japanese word. Okay? Very good. Hey, you like that taste? Right? It's like how Eve got her name, right? Whoa, man. Right. Yeah, right. Good. Good. Taste specific. So here are the 5 sensations, right? Sweet receptors are plentiful. Stay with me. Near the tip of the tongue. Sours along the lateral edge. Salt is abundant in the tip as well as the upper portion. Bitter is the back of your tongue. And this umami receptors, they respond to certain amino acids like MSGs and such. I thought there was a map here on this, but there is not. So let's see if we can't pull one up real quick. One second. Yeah, so... They don't seem to have that. Yeah, I mean you can see. I guess that one's not bad. These different areas. Where is the umami? I don't know. That's what this one says. We're not sure exactly where they are.
Question mark? Do some people?
Yes.
Some people have sections of their tongues that are like more like I don't know jaded or like used to certain bitter taste and stuff like that. And so they might
Sure. So why someone likes very spicy things or can tolerate that more? Is that what you're saying? Like a toleration?
Like salt. Like my mom, she does not like salt because my dad loves salt.
Ah, okay.
Like what makes a person more tolerant?
Yeah, I don't know. I don't know if it's. I would say it's not. It may be that they have more heightened receptor. Like your mom is very sensitive in that taste area. It could be that it's associated with something else. Like maybe she had to eat something very salty in the past and did not like it at all. And so, likes and dislikes are, oftentimes it's not an anatomical or a functional reason why. It's usually associated with something else. But I don't know. I don't know, to be honest.
Do you think that they adapt?
I think definitely they do adapt, yes. So if you're eating a lot of sweet things, and this is, I've had some very good friends who have gone on some diets that basically they cut out all sweet things totally for a period of time. And after, let's say, a month of this, you give them something that you and I might not think is sweet at all, and they're like, whoa, it's so sweet, because their taste buds are not used to that. And now those are being stimulated again, and it takes a little or less sweetness to stimulate that. So definitely, you do have that. That's no doubt about that. Sir?
How come you taste spicy when you have that?
My understanding of spicy, because it's not one of the actual pieces here, is that it's actually not causing damage per se, but yeah, it's affecting all of those tissues, not just the taste buds. All of that epithelial tissue throughout your mouth. Yeah. Into your throat, into your stomach, depending on. Have you ever had spicy food that was so good, but yet it hurt? Oh, man. Some good Indian food. I'm telling you. We were in, the best Indian food we've ever had, we were in England in 2000. And this little restaurant in Winchester, this little tiny town outside of London. And it was like painful. It hurt to eat, but it was so good. You just wanted to keep eating. Oh, but it hurts. Oh, but it's so good. Yeah. Good stuff. Sir? It says to.
That you can taste everything on all parts of your body.
I know that there is some controversy. Yeah. And I'm not going to say that it's not. I will say this is what your book talks about. So it very well may. I wouldn't be surprised if you could see other things in different places, but maybe they're more concentrated, certain tastes in certain areas. But I wouldn't be surprised if it goes throughout. Yeah. Okay, what's happening here? And again, here's what they say, kind of addressing that exact thing, Matthew, that taste buds may be responsive to at least 2 taste sensations, but one is likely to dominate. So even though the same bud could have like both sweet and sour, but usually it tends to go one or the other. Okay? And again, those do rapidly adapt.
Can you damage it so much that you can't taste it?
Sure. Yeah. Have you all ever, again, I think of just burning your mouth on a hot drink. You know? Yeah, you burn like the tip of your tongue, and then you can't taste. Yes? Well, that can be just the actual acid in the food can just eat off some of that tissue. Yeah, acids, they do like those kind of tissues. Yeah. Okay, how does the pathway work for your taste nerves? Well, it travels up the facial nerve, glossopharyngeal, and the vagus nerve into that gustatory cortex, the part of your cerebrum that deals with taste. Any questions there? We're done at 50, right? Smell. I think, okay, we'll go one more. One more little piece. We'll do all of the sense of hearing here. Let's jump into that. Where am I at now in your textbook? This is over here on page 270. Sense of hearing. Because this one is much more complex. The tongue, the nose are fairly straightforward, fairly simple processes that make you be able to taste and make you be able to smell. Hearing is a little bit more complex. So let's start just simply with the anatomy of this thing. This is a diagram that you will have to know for your test. On your study guide, it mentions that you need to know this guy. The anatomy of how you hear. Okay? So we'll start with this. It's no longer known as your ear. Now you are educated enough to say that that is the auricle on the outside of your head. Anyone know what the purpose of this thing is? You know, besides hanging earrings off of? Ooh, good. Yeah, it's taking that sound and collecting it and putting it in here. Yeah, do this for me. Put your hands like this around your ears. And you can really, it's like suddenly you've got super hearing. Whoa. Do you hear that it also makes you sound louder to yourself when you talk?
Hey, Christian. I know. Tinier ears, then does that mean you don't like hear?
Good question. Come back to me. So Hannah says, shh. So Hannah says,
I have terrible hearing. My ears are really small.
I would suppose on a theoretical level, perhaps you can't capture as many sound waves, but that wouldn't necessarily affect how well you hear. You know? Yes? Shh.
Orchestra practice, so I play the French horn, right?
Yeah,
And my neighboring, a guy next to me, had a detachable bell.
sure.
So I detached it and I put it against my ear.
Yeah.
This big. And I could hear it.
It's like super, right? Super hearing. That's cool. Okay? So that auricle funnels, takes that sound, because again, we hear mostly what's in front of us, right? You can hear some things around other places, but our senses are all focused where we're looking, right? You know, there are some animals that can move their ears like all directions, right? Almost 360 to hear all around. These would be animals who spend the majority of time trying to be still and not hunted, right? So, because if they moved, the predator would see them, right? Whereas we're usually the predator, so therefore, not as important. So it takes and funnels that sound into what they call the external auditory meatus. Remember, the meatus is the actual hole, right? But this is the canal, external auditory canal. It's not labeled on that diagram, but that's really what it's called. And it gets us to here, the tympanic membrane, or your eardrum. Okay? And you all have heard of these before, right? This is all old school. You know this stuff. Okay? So those, what did I do with my pen? Here it is. Attached to that eardrum are these little tiny bones. These are the smallest bones in your whole body. The malleus, the incus, and the stapes. This is how big they are. Now that's a penny, and you got all three bones that aren't even close to the size of that penny. It's tiny, right? Sure, these are the Latin names for them, but yes, the hammer, the anvil, the stirrups. Right. This looks like a stirrup, right? Like a horse stirrup, right? This is an anvil, right? Like the thing that you pound metal. And this is a hammer, right? So these are Latin words for that. Incus, malleus, stapes. They are tiny. I mean, that is, sure, yeah. Penny is what? This big, right? And these are tiny little bones. Tiny little bones. So what do they do? And this is where I'm going to leave you today. This is where I'm going to leave us off here. Sound waves come in, right, friends? Through that auricle. The auricle gathers them, sends them through that canal. They take and they make that tympanic membrane vibrate. But are you comfortable? These are fairly small vibrations, right? These bones are attached. First the malleus, then the incus, then the stapes. And that stapes is attached to the oval window on your cochlea. The cochlea is where the actual receptor cells are that you hear with. Let me show you this. It would be like this. If this is the tympanic membrane, the oval window is like this. Size-wise, it's significantly smaller. And then these bones connect the two things to that. Any idea why? Why it's designed in this way? That we're taking this larger something and moving it into a smaller opening. Trying to confine it. Okay, keep going. Converting. Okay, converting how or to what? Or Okay, so you can hear what you really need to hear. You're all around it. You're doing well, friends. Keep thinking. You're funneling, okay. You're taking it from a large thing and moving it to a small thing. What does that do to the sound? It amplifies it, right? It's taking these tiny vibrations of this bigger eardrum and making them much larger once they get down here. Does that make sense? The point of this tympanic membrane into the oval window, this is a test question, by the way, is to amplify that sound. And that's what those bones do. They transmit those vibrations from here directly into that oval window. Does that make sense? It seems like quite a complicated arrangement, to get sound from the outside to the inside. But the point is to amplify. You see a lot of these things and you're like, wow, okay, that sure does look like someone designed that very nicely, Yes, ma'am. Well, it can cause damage to those pieces. We look at the diagram here. If this thing ruptures, how does it rupture? From overpressure, like a bomb going off or an explosion going off. There's a pressure wave that can do that. Sticking a Q-tip too far in there, you can damage that. Yeah, not a good plan. Right? Very loud noises can cause so much vibration that it tears. Usually that will heal. Like you're not permanently deaf. Sure. Right, no. There could be something here that gets messed up, but usually that membrane is just what tears. And it's got blood supply, that's why it bleeds. Yeah.
When people are deaf, isn't the problem with the transmitting the signal to the brain or something in the ear?
It can be any of those things. It can be a structural problem here, and we'll talk about what actually happens in the cochlea. It can be the nerve that transmits to the brain. It can be in the brain itself. There are lots of different causes for it. Yeah. That's usually a problem with the receptors themselves. We'll talk about that, those actual pieces. I would keep going, but we don't have too much time remaining. Okay, again, this is 10.7, sense of hearing. So I wanted you questions through 10.6 for tomorrow, but I will encourage you to keep on doing your reading. Right? We're just rolling through. Sense of hearing is much more complicated here. Balance is next, equilibrium. And then the big one, your vision. The vision is much more complicated, the most complicated of these senses that we'll talk about. Any other questions before I close out this recording?